Hi guys, this is the EdExcel GCSE Maths 91 paper 2 from the higher tier, and it's from the June 2019 series, and it's a calculator paper. For question 1, we have to solve 4n being greater than 11n plus 6. If we subtract 11n from both sides, so if I subtract 11n from the left hand side and 11n from the right hand side, we have 3n being greater than 6, and then if we divide both sides by 3, so if I divide the left hand side by 3 and the right hand side by 3, we can therefore see n is greater than 2. So we have n being greater than 2. And now for part B of the question, on the number line below, we have to show the set of values of x for which minus 2 is less than x plus 3, which is less than or equal to 4. And the way we approach this, we want x by itself, so we would have to subtract 3. So I subtract 3 from minus 2, I subtract 3 from 4, and I also subtract the 3 from x plus 3. And if I do that, we end up with minus 5, which is less than x, which is less than or equal to 1. And now when we show this on a number line, we would end up with the following. And notice, for this strong inequality, we have an empty circle. For this weak inequality, we have a filled circle. Question number 2. On the grid below, we have to draw the graph of y equals 2x minus 3 for values of x from minus 2 to 4. And if we do that, we can use our calculator. Of course, on the calculator you can access the table option. We type in our function, we have 2x minus 3, and we want to plot this from minus 2 to 4. We will go up in ones, so when x is equal to minus 2, y that's equal to minus 7, and also when x equals 4, y equals 5. So when x is 2, y is equal to minus 7, that's over here somewhere. And when x is 4, y is equal to 5. So when we plot this, we have the following. And you'll also notice the graph crosses the y-axis at minus 3. That's when x is equal to 0. And we see that over here. For question number 3, Hannah is planning a day trip for 195 students. She asks a sample of 30 students where they want to go. Each student chooses one place. The table shows information about her results, and we have to work out how many of the 195 students you think will want to go to the theme park. Well, over here we have a sample of 30 students. We have over here 10 people of those 30 who said they want to go to a theme park. So in terms of the amount of students who want to go to the theme park, we have 10 out of 30. That's for this particular sample. And if we consider the entire population of 195, multiplying this by 195, we end up with 65. So therefore, we have 65 students who want to go to a theme park. And now for the next part of the question, we have to state any assumption we made and explain how this may affect our answer. So over here, the sample is representative, so the 30 students is representative of all the 195 students, and if we don't have a representative sample, the answer would be wrong. Okay. Question number 4. A container is in the shape of a cuboid, and the container is 2/3 full of water. A cup holds 275 milliliters of water. What is the greatest number of cups that can be completely filled with water from the container? So for this question, first of all, we can consider the volume of the cuboid. So the volume of the cuboid, that's equal to 30 centimeters multiplied by the 6 centimeters multiplied by the 19 centimeters, and if we work out the volume, 30 multiplied by 6 multiplied by 19, that turns out to be 3420. Now, the container is 2/3 full of water, so we can find out the volume of water we have. Okay? So here we have the volume of the cuboid being 3420 centimeters cubed. So the volume of water we have that will be equal to 2/3 of this amount. So we have 2/3 multiplied by 3420, and if we work that out, so times this by 2/3, we end up with 2280. Okay, so the amount of water we have, therefore, is 2280 centimeters cubed, and therefore the number of cups we have, bearing in mind one cup holds 275 milliliters, the number of cups we require will be 2280 divided by 275, and if we work this out, so if I divide this by 275, we end up with 8.29, etc. So in other words, we require 8 cups. So our final answer, we require 8 cups. Question number 5. ABC is a right-angled triangle, and we see that AC is 16 centimeters. The angle ACB is 38 degrees. We have to calculate the length of AB to 2 decimal places. The first thing we do with this right angle triangle is recognize that this 16 centimeters is opposite the right angle, it's the largest side, and therefore AC is the hypotenuse. We're finding out AB. AB is the opposite. What connects the hypotenuse to the opposite is the sine. So we have over here sine of 38, that's equal to the opposite, which is AB, over the hypotenuse, which is 16, and we can therefore work out what AB is. AB is equal to 16 times by the sine of 38, and if we work all of this out, 16 times by the sine of 38 degrees, that's equal to 9.85 to 2 decimal places. So we have 9.85 centimeters to 2 decimal places. So let's just add this into our diagram. Here we have 9.85. For question 6, Sally used her calculator to work out the value of a number y. The answer on her calculator began 8.3. we have to complete the error interval. Well, if the answer on her calculator started with an 8.3, we can see here that 8.3 is less than or equal to y. Now, obviously, we can't have 8.4, otherwise the number won't start off with an 8.3. So y is less than 8.4. Question number 7. £360 is shared between Abby, Ben, Chloe and Denish. The ratio of the amount Abby gets to the amount Ben gets is 2 to 7. Chloe and Denish each get 1.5 times the amount Abby gets. We have to work out the amount of money that Ben gets. Well, we can see over here 1.5 times by the amount Abby gets, that would be 1.5 multiplied by 2, which is 3. So therefore the ratio A to B to C to D, that's equal to 2 to 7 to 3 to 3. Notice 2 multiplied by the 1.5 gives a 3. So Chloe and Denish each get 3. So £360 is shared between these 4 people. First thing we can do is work out the number of parts. So the number of parts, that's equal to 2 plus 7 plus 3 plus 3, which is 15. And therefore the amount per part, that will equal 360 over the 15, which is 24. And therefore the amount that Ben gets, he has 7 parts, so therefore Ben would get 24 multiplied by 7, which turns out to be 168. Okay, so Ben gets £168. Question number 8, we have to write 0.00562 in standard form. Well, all we have to do over here is multiply we have to move the decimal place to the right such that the number will be of the form a times by 10 to the power of n, where a is in between 1 and 10. Okay? So if we move the decimal place, we move it 1, 2, 3 units to the right. So therefore we end up with 5.62 times by 10 to the power of 3, minus 3, because we moved to the right. And now for part B, we have to write 1.452 times 10 to the 3 as an ordinary number. Well, we have this 1.452, and if we move the decimal place 1, 2, 3 places to the right, because we're multiplying by 10 to the power of 3, we therefore end up with 1452. Question number 9. The circumference of circle B is 90% of the circumference of circle A. We have to find the ratio of the area of circle A to the area of circle B. So here we've got circle A and here we've got circle B, and B is, the circumference of B is 90% of that of circle A. So to go from A to B, we multiply by 0.9. So this multiplication of 0.9, that represents the length scale factor. So the length scale factor, that's equal to 0.9. And therefore the area scale factor, that will be the square of 0.9. So the area scale factor, that's equal to 0.9 squared, which is 0.81. So to go from A to B in terms of an area, we multiply by 0.81. And therefore, the ratio of A to B, that will be 100 to 81. Okay? For part B of the question, square E has sides of length E centimeters, square F has sides of length F centimeters. The area of square E is 44% greater than the area of square F. We have to work out the ratio E to F. So for this question, we see over here E is 44% greater than the area of F. So to go from F to E, we multiply by 1.44. So this 1.44 would represent the area scale factor. And therefore the length scale factor, that would represent the square root of the 1.44. So the length scale factor, that would be 1.2. So therefore, the ratio of E to F, that will equal 1.2 to 1. And if we write this in terms of whole numbers, multiplying through by 5 to get this to involve no decimals, we have 6 to 5. Okay. Question number 10. Mary travels to work by train every day. The probability that her train will be late on any day is 0.15. And we have to complete the probability tree diagram for Thursday and Friday. Well, the probability that she is not late, that's 0.85. So here we have 0.15, that's when she's late. 0.85, that's when she's not late. 0.15, that's if she's late. 0.85, that's if she's not late. And for part B, we have to work out the probability that her train will be late on at least one of these 2 days. So the probability that she's late on at least one of these 2 days, that's given by 1 minus the probability that she's not late on 2 days. So we have 1 minus the probability that she's not late on a Thursday, which is 0.85, and also not being late on a Friday. So working this out, 1 minus 0.85 times 0.85, that will be 0.2775. Okay, so that's our probability. So we have over here 0.2775. Question 11. The grouped frequency table gives information about the times in minutes that 80 coffee workers take to get to work. And the frequency is shown here, and we have to complete the cumulative frequency. Well, we begin with the 5. 5 plus 30, that's 35. 35 plus 20, that's 55. 55 plus 15, that's 70. 70 plus 8, that's 78. And 78 plus 2, that's 80. And now for part B, we have to draw the cumulative frequency graph for this information. So we have something which looks like this. Obviously your graph in the exam will be a lot more smoother. And now for part C, we have to use our graph to find an estimate for the percentage of workers, for the percentage of these office workers who take more than 90 minutes to get to work. Well, if we plot the 90 minutes, we'll do this in a different colour. 90 minutes, that's over here somewhere. Okay, and then if we draw a horizontal line across you can hopefully see that corresponds to a value of about 75. So here, those who took more than 90 minutes, that will be over here 5 workers. So therefore we have 5 out of the 80 who took more than 90 minutes, and then to convert this to a percentage, multiply by 100. So therefore 5 divided by 80 multiplied by 100, we end up with 6.25%. Question number 12. OAB is a sector of a circle with centre O and radius 7 cm. The area of the sector is 40 cm squared. We have to calculate the perimeter of the sector. Give your answer correct to 3 significant figures. So first of all, you need to recognise that the area of a sector, that's given by theta, the angle, divided by 360, multiplied by pi r squared. Okay, and the perimeter of the sector, well, for us to work out the perimeter, we first of all have to work out the arc length. So the arc length, that's given by theta over 360 multiplied by 2 pi r. So with this, we know what the area of the sector is, we know what the radius is. With this, we can find the unknown theta, that's the angle AOB. So we have 40, that's equal to theta over 360 multiplied by pi times by 7 squared. So we can rearrange for theta. Theta is going to equal 40 times by 360 divided by pi times by 7 squared. So if we work this out, we get 93.5, etc. So this angle over here is 93.5, etc. degrees. So with that, we can now find out the arc length. So the arc length AB, that's equal to theta, which is 93.5, etc., over 360, multiplied by 2 pi r. So we multiply by 2 times by pi times by 7. So we divide this by 360, and then we multiply this by 14 pi. We end up with 11.42, etc. So here, AB, that's 11.42, etc. And therefore the perimeter P, that's equal to 11.42, etc. plus the 7 plus another 7. So if I add on 14, we end up with 25.4. Okay, so here we end up with 25.4 centimeters to 3 significant figures. So let's add that in here, 25.4. Now for question number 13, we have to show that 6 plus x plus 5 divided by x squared plus 3x minus 10 over x minus 1 simplifies to ax minus b over cx minus d, where a, b, c and d are integers. So over here, first of all, we can factorize the x squared plus 3x minus 10. So we have 6 plus x plus 5, which I'm going to rewrite as x plus 5 over 1. And then we're going to divide this by, on the top here, if I factorize, we have x plus 5 lots of x minus 2. And on the bottom we've still got this x minus 1. Now, when we divide fractions, we flip the second fraction and we change the divide to a times. So we have 6 plus x plus 5 over 1 multiplied by x minus 1 over x plus 5 lots of x minus 2. And at this point, hopefully you can see the x plus 5s cancel on the top and the bottom. So we are left with 6 plus x minus 1 over x minus 2. And to combine these, we can write these over a common denominator. So the 6 we can rewrite as 6 lots of x minus 2 lots of over x minus 2. And then we're adding on x minus 1 over x minus 2. So here we have 6 lots of x minus 2 plus x minus 1 on the top, and on the bottom we have x minus 2. So if I expand on the top, we have 6x minus 12 plus x minus 1. On the bottom we have x minus 2. We can simplify this to 7x minus 13 over x minus 2. So therefore our final answer is 7x minus 13 over x minus 2. Question 14. A car moves from rest and the graph gives information about the speed v meters per second of the car t seconds after it starts to move, and we have to calculate an estimate of the gradient of the graph at t equals 15. So over here we have to draw a tangent when t equals 15. And if I draw a tangent, we end up with something which looks like this pretty much. So let's just try to get this as accurately as we can. We have something which looks like this. Okay, so this is a tangent at t equals 15. And now for us to find out the gradient of this tangent, we would have to use the change in y over the change in x. So the change in y we can find from here. Okay, so here the change in y, that's equal to 25 take away 7.5. So let's just work that out. 25 take away 7.5, that's equal to 17.5. The change in x, we are going from 0 to 25, so therefore the change in x, that's equal to 25. So therefore the gradient, that's given by the change in y over the change in x. So here we have 17.5 divided by 25. So if I work this out, 17.5 divided by 25, that's equal to 0.7. So the gradient is 0.7. And now for the next part, we have to describe what this represents. Quite simply, the gradient would represent the acceleration. So the gradient of a tangent from a speed time graph, that represents the acceleration. How do I know that? Because if I think about the units that we're using over here, let's just write the units down. For the units we have over here 17.5 meters per second. On the bottom, the time that has unit seconds, meters per second per second. This represents obviously meters per second squared. So this represents 0.7 meters per second squared, which obviously represents the acceleration. And now for part B, we have to work out an estimate for the distance of the car travels in the first 20 seconds of its journey, use 4 strips of equal width. Well, the area underneath represents the distance travelled. So we want to use 4 equal strips in the first 20 seconds, so we can split this up into the following. So here we've got 4 equal widths from 0 seconds to 20 seconds, and then because we're finding out an approximation of the area, we can split these up into simpler shapes. So here we've got a triangle, and then we've got trapeziums everywhere else, as shown here. And for us to work out the total area, we simply have to add up this triangle to these trapeziums here. So if we do that, the area of the triangle, that's given by a half times by the base times by the height. So we have a half times by the base, which is 5, times by the height, which is 4. So here we have 1/2 times by 5 times by 4. For the first trapezium, we have a half AB, so we have a half lots of A plus B times by H. So we have a half times by 4 plus 12 times by 5 times by a half. So here we have a half lots of 4 plus 12 times by 5. For the next one, we have a half times by 12 plus 18. So we have 12 plus 18 times by 5. And then for the final one, we have a half times by 18 plus 20 times by 5. And if we work all of this out, we end up with 220. So an estimate for all this will be 220 meters. And now for question 15, we have to make m the subject of the formula f equals 3m plus 4 lots of m minus 1. Well, if I multiply both sides by m minus 1, we have f lots of m minus 1, which is equal to 3m plus 4. If I now multiply this out on the left hand side, we have fm minus f equals 3m plus 4. Gathering all the terms that contain an m on one side, everything that's not an m on the other side, we have fm minus 3m, which is equal to f plus 4. So here, if I factorize out the m, we have m lots of f minus 3, and this is equal to f plus 4. Dividing through by f minus 3, we can therefore see that m is equal to f plus 4 over f minus 3. So that's our final answer. Question 16. A straight line L has the equation 3y equals 4x plus 7. Point A has coordinates 3 minus 5. We have to find an equation of the straight line L that is perpendicular to L that passes through A. So for this question, for us to find out the gradient of L, we have to rewrite it in the form y equals mx plus c, and we can do that by dividing both sides by 3. So the equation of L, we have y equals 4 over 3x plus 7 over 3. So therefore the gradient is equal to 4 over 3. So therefore the perpendicular gradient, that's going to equal minus 3/4, the negative reciprocal of 4/3. Now, we can find out the equation of the straight line by using the formula y minus y1 equals m lots of x minus x1. y1, that would be the 3. Sorry, x1, that will be the 3. y1, that will be the minus 5. So substituting everything in, we end up with what minus 5 equals minus 3 over 4 lots of x minus 3. So if I tidy all this up, we can see that we have y plus 5 equals minus 3/4 lots of x minus 3. And we can expand this out into an alternative form if we wish, but there's no need to do that. Question 17. There are some small cubes and some large cubes in a bag. The cubes are red or yellow. The cubes are red or the cubes are yellow. The ratio of the number of small cubes to the number of large cubes is 4:7. The ratio of the number of red cubes to the number of yellow cubes is 3:5. We have to explain why the least possible number of cubes in the bag is 88. Quite simply, the lowest common multiple of the 4 plus the 7, which is 11, and the 3 plus the 5, which is 8, the lowest common multiple of 11 and 8, that's 88. And now for part B, all the small cubes are yellow. We have to work out the least possible number of yellow large cubes in the bag. So the ratio, already what do we know? We know that the ratio of small to large, that's equal to 4:7. Okay? Now if we know that the lowest common multiple is 88, then over here, the number of small we have, 88 divided by 11, that's 8. So 8 times by 4, that's 32. And therefore, 8 times by 7, that's 56. Okay? So the ratio of small to large, that's 32 to 56 at least. Okay? And in terms of red to yellow, similar thing. Red to yellow, we have the ratio 3:5. So using the lowest common multiple, 88 divided by 8, that's 11. So 3 times by 11, that's 33. 5 times by 11, that's 55. So what does this tell us? It tells us that 55 cubes are yellow. So here we have 55, which is the number of yellow cubes. And over here, 32 of those are small. So therefore, this over here represents the small. So therefore, here we have 23 yellow large. Okay? So we have 23. Question number 18. The points A, B, C and D lie on a circle. CDE is a straight line. BA is equal to BD. So we have an isosceles triangle. CB is equal to CD. Again, we have an isosceles triangle. We have to work out the size of the angle ADE. You must give a reason for each stage of your working. Well, first of all, BAD, that's going to equal DAB because we have an isosceles triangle. So we have 180 take away 40 divided by 2. So we have 180 take away 40 and divide that by 2. We end up with 70. So the reason here, the base angles on an isosceles are equal. So what does that mean? It means over here we have 70 degrees, and it also means here we have 70 degrees. And also you'll notice we have a cyclic quadrilateral. So with that we can find out the angle BCD. So the angle BCD, bearing in mind the opposite angles in a cyclic quadrilateral add up to 180, BCD, that's equal to 180 minus 70, which is 110. So what does that mean in terms of the diagram? Here we have 110. So we can now state the reason for this. The opposite angles in a cyclic quadrilateral add up to 180. And again, similarly, because we have an isosceles triangle, we can work out the angle DBC and the angle CDB. So here, next, the angle DBC, that's equal to the angle CDB, which is equal to 180 minus 110 divided by 2, which is 35. So here we have 35 degrees, and here we also have 35 degrees. So let's state the reason for this. The base angles on an isosceles are equal. And finally, because we know that CDE is a straight line, angles on a straight line add up to 180, so the angle ADE, that's equal to 180 minus the 70 minus the 35, which is 75. So this angle here is 75. The reason for that, angles on a straight line add up to 180. Question number 19. The diagram shows a triangular prism as shown here. The base ABCD of the prism is a square of side length 15 centimeters. The angle ABE and the angle CBE are right angles. The angle EAB is 35 degrees. M is the point on DA such that the ratio DM to MA is 2 to 3. We have to calculate the size of the angle between EM and the base of the prism. Give your answer correct to 1 decimal place. So what's this question asking for? Well, M is a point on DA such that the ratio DM to MA is 2 to 3. So what does this mean? It means over here that somewhere here we've got the point M. And in this question, the angle we're looking for is somewhere over here. Okay, so perhaps if we show this in a different color, if I draw the triangle which we require this triangle over here in blue, and we want this angle here. First thing we can do is find out the length DM. Well, if DA is 15 centimeters, DM using this ratio, here we have 5 parts altogether. 15 divided by 5, that's 3. So 3 times by 2, that's 6. So here we have 6 centimeters, and here we have 9 centimeters, and those add up to give 15 centimeters. So we can use Pythagoras now to find out what MB is. So MB, that's equal to 9 squared plus 15 squared square rooted. So working this out, here we have 9 squared plus 15 squared square rooted, which is 3 root 34. So if I add this to the diagram, here I have 3 root 34 centimeters. Okay, we can now find out the length EB using trigonometry. If we consider the triangle ABE, the 15 over here represents the adjacent. This over here represents the opposite. What connects the opposite to the adjacent is tan. So here we have the tan of 35 degrees, which is equal to the opposite EB over the adjacent 15. So therefore EB, that's equal to 15 times by the tan of 35. So let's add this into the diagram. Here we have 15 tan 35. Okay, so let's just get rid of this for a second. So now what we can do is, knowing this length here and this length here, we can find out this angle here. So to find that out, here this 3 root 34, this represents the adjacent. This here represents the opposite. Again, what connects the opposite to the adjacent, that's tan. So here we have tan theta, that's equal to 15 tan 35 divided by 3 root 34. Okay, so let's just get rid of these annotations here. And with that, we can work out what the angle theta is. So theta, that's going to equal the inverse tan of 15 tan 35 divided by 3 root 34, which is 30.98. Okay, which to one decimal place, that's 31.0. Question number 20. CDEF is a quadrilateral, as we see over here. CD, that's equal to the vector A, so let's just add this to the diagram. DE, that's equal to the vector B, so that's B over here. And FC, that's equal to A minus B. We have to express FE in terms of A and or B. So F to E, we have to start at F, finish at E. So FE, that's going to equal FC plus CD plus DE. So FC, we know that's A minus B. CD, we know that's A. DE, we know that's B. So here we end up with 2A. So FE, that's equal to 2A. So actually what we have over here is a trapezium, because we have two parallel sides. And now M is the midpoint of DE, so if M is the midpoint, here we have a half B, and here we also have a half B. And X is the point on FM such that the ratio Fx to Xm is n to 1, and CXE, so CXE, that's a straight line, we have to work out the value of n. So what we can first of all do is we can work out the vector Fm. That might be quite useful. So if I work out the vector Fm, that's equal to Fc plus CD plus dm. So Fc, that's equal to A minus B. CD, that's equal to A. And dm, that's equal to a half B. So therefore this turns out to be 2A minus 1/2 B. Okay, now Fx, we can also work that out. Using the ratio over here, we have n plus 1 parts in total, and Fx is therefore n over n plus 1 lots of Fm. So let's just write that down. Fx, that's equal to n over n plus 1 lots of Fm. So here we have n over n plus 1 lots of 2A minus 1/2 B. Okay. Now what else can we figure out from this? Well, we can find the vector CE because we know that CXE is a straight line. So let's work out CE, and let's also work out CX from that. So the vector CE, starting at C, finishing at E, we can go to D first, and then we can go to E from D. So working this out, we end up with A plus B. Okay, that makes sense. We start over here and we end up here, so we got A plus this B. So therefore CX, the vector CX, that's going to equal CF plus Fx. Now, do we know CF? Yeah, we do. That's going to go the other way. So that's B minus A, or minus A plus B. And then we add on Fx, which we just said, that's n over n plus 1 lots of 2A minus 1/2 B. So let's actually simplify all this, if we can. If we simplify all this, we have minus A plus B plus n over n plus, well, 2n over n plus 1 lots of A minus n over 2 lots of n plus 1 B. And if we gather all the terms involving an A, we have 2n over n plus 1 minus 1 a plus 1 minus n lots of 2 over n over 2 lots of n plus 1 b. And we know that cx is a straight, so cxe is a straight line, so therefore cx is some multiple of ce. So in other words, if you look at CE that was worked that out to be a plus b, so therefore the ratio of the components must be the same. In other words, you can see over here the a component is equal to the b component from CE, so therefore a is equal to b. So if we set the a vector equal to the b vector, we have 2n over n plus 1 minus 1 equals 1 minus n over 2 lots of n plus 1. And if I simplify all this, we have 2n over n plus 1 plus n over 2 lots of n plus 1, and that's equal to 2. And if I write this over the same denominator, so here we want a 2 lots of n plus 1, on the top we have 2 lots of 2n, because the 2's cancelled to give the 2n over n plus 1, and then here we have n over 2 lots of n plus 1, and this is equal to 2. So here we have 2 lots of 2n plus n over 2 lots of n plus 1, and this is equal to 2. So if I expand and simplify, we have 4n plus n on the top. On the bottom we have 2n plus 2, and this is equal to 2. So on the top we have 5n, and if I multiply through by 2n plus 2, we have 2 lots of 2n plus 2. So we have 5n equals 4n plus 4, so therefore n is equal to 4. That's our final answer.